under this lesson, measurement associated with electricity, we just learn about, so what is voltage? What is voltage? Voltage means basically, so when you connect the batteries to a circuit, the gap between 2 points. So the gap between 2 points over the, you can just simply say that is the range, right? Range, actually that gives the pressure. So when the gap is high, the pressure will be high. There is a big gap, the pressure will also be high. So actually we can use this galvanometer and milliammeter. So actually these are called like middle center zero galvanometer. So center zero galvanometer means like it moves both direction. So actually this can be used to measure the direction of the current also. That is why we are using center zero galvanometer, but there are some galvanometers, it is not center zero, it's in the corner. So then you can measure, it's only one side, but center zero one measuring both sides, right? And why milliammeter? Because we are going to measure very small currents. We can use ammeter, but we are not going to measure amperes. We are going to measure milliamperes, so milliammeter is enough. Actually, instead of that, you can use something called multimeter. So I'll show you an image of multimeter. Multimeter has, like, let me show that first. Okay, I'm not sure whether I got it now. Just give me a second. I'll show it to you. Right. Then basically, so this multimeter can be used to measure both voltage as well as amperage. Both can be measured, and also the resistance, everything can be measured. So it is a single device that at least, so it's like buying this separately to a home environment is not easy. So you can use, instead of that, you can just use this multimeter part, this one. I guess you can see this. Can you? Let's pin the video and stop sharing the screen. You can see this. This is what the multimeter is. I think you can see this, and here we are in off, but we can just turn on. Actually here, when this settings, so basically it is used to measure, in this settings we can measure voltage of something. And so here, if you change this to this one, this is to measure the amperage. Actually in that case you have to turn this other side to measure the amperage. Likewise, everything can be measured, but actually the multimeter lesson is not there in your syllabus, but it's very easy to measure some voltage using this. But I don't have a battery here, so let me check whether there's a battery, then I can show you the measurement too. Right, let me show this also. You can see there's a battery, and actually I have to put this positive to positive edge, then the negative to negative edge. I'm not sure you can see this clearly here. Positive to the positive edge, negative to negative edge, and I check this. It's very difficult to do this. This is very small battery. Okay. So let's see. I think you can see this. It shows the voltage. So can you read the figure and tell me what you can see? So the mirrored image is displayed back to me. So you have to reverse read it like, so I think you are seeing the correct image, right? Is it mirrored one or other side? Which side you can see? You can see, I think, correct side, right? So what is the value? Hello?
1.31.
1.31. That is here. This is very small. You know, this is AA battery. We learned about batteries last day. This is AA battery. This shows, this figure shows actually here. Okay, this is, so can you read it? So maybe it says 1.2 volt, right?
Yes.
You can see 1.2 volt. And then the next is the milliampere, mAh, milliampere hours. That is 2450, 0.2450. That is the minimum milliampere hours. So that is also displayed here. So voltage is 1.2, but so normally in a charged battery, you can see more than that. Right? It's well charged battery. Basically 1.2 is the minimum. That is basically more than 1.2. That is why you can see 1.3 there. Anyway, so that is the multimeter. Multimeter can be used to measure voltage as well as, but this is not something center zero. The center zero one is analog, right? It is analog. It has a meter like this, but this is a digital one. The Mangala pen is digital. Samana center zero one is analog. Analog is C center zero galvanometer. And let's see how it works. Unfortunately, you don't have, so this is bit old one. Center zero one you can see using animation, but yeah, now actually devices are digital, that's the main reason. But anyway, let's see this one. Not sure whether the exact one in your lab, in school science lab.
You might have seen videos like this before, but here's.
But yeah, this is animation, right? Because you know these devices are not there. This has a magnet. So this magnet, because you know when there is a magnet, right? The magnet just because of this magnetism it rotates. Because when there is like power in a copper or iron wire, right? When it is conducting some electricity, there will be a magnetic field created. I think you have done this experiment in your grade 6 or grade 5 maybe. So using a nail and copper coil. So you have to create small magnet. Actually, this magnet is a temporary magnet. So this image, I think you have done similar one in your school age. So something like this here. So use a copper wire and wrap it around the nail, and then nail or iron core, then provide some voltage using a battery. Actually, when you provide electricity using a battery, what will happen? It will act like a magnet. It will act like a magnet, but when you disconnect the power, the magnetism will be removed. That is the reason is when there is a power around this, there will be a magnetic field created like this. Okay, when this magnetic field thing is there in the middle and there are two permanent magnets, what will happen? So because of the center magnetic field, it will rotate. That rotation is used to measure the here voltage and all. Actually, that is measured using this rotation. That is what the manual galvanometer is. Actually, you don't have these calculations. This is too heavy. That is why I just want to show you just the galvanometer image. But so it's okay. This is there now. But it is also about
Explain
how
how a
galvanometer
galvanometer works. This question is asking for a bit of a sort. force in the other direction due to the motion to see how far the needle is deflected.
Still, it is not the one. Okay, this one at least. Okay, see here. This is the other version, right? It is not having a center zero. Okay, these calculations, let's skip that anyway, just see the image. So this image is there. So when you put this, when you turn on the switch, what will happen? Right, when you turn on the switch, there will be a voltage. So it will be measured by this. Actually, the milliammeter will measure the amperage. This is image of milliammeter. It's measuring the amperage, and galvanometer can be used to measure the gap. Okay, that is the right. So this part we have learned. Right. Then actually, so here, so we learned that the voltage is the potential difference. We have already learned that the voltage is the potential difference. That means the difference between the highest position and the lowest position. So it is like this. Let me show this image to you. You can see, so if there is a tank like this, from the highest position to the lowest position, the gap we can call the voltage. It is the difference between the charge. Actually, here you have a lot of electrons. Let's see, there are a lot of electrons here, less amount of electrons. The gap between this is basically the electrical charge gap is called voltage. And current is basically, so when you cut or when you take from this pipe, so what is the amount of charge flowing? The amount of charge which is flowing. You can see here the pipe is larger, here the pipe is smaller. So which has higher flow? Is it the right side, left side one or right side one? Which has higher flow? Left side or right side has higher flow?
Left side.
Left side is, you can see the pipe size is high, so therefore higher flow. So similarly, when you see something like this, you can say here the amperage is high. Amperage will become high when the flow is high. Actually, height decide the voltage, and the amount of electrons, amount of charge which flow, we call it amperage. The resistance is actually the force which is blocking the flow. Something like this. Okay, you can see there are two pipes. The first pipe is allowing the flow, so it has less resistance, but the second pipe, you can see the resistance, or it is not allowing that similar flow. There is a resistance to that flow. Actually, the tendency to resist the flow is called resistance. So that is the third property that we have learned. Okay, I think better you write down this part, right, very quickly. Did you write this last day?
No, sir.
Right, okay. Then shall you write it quickly? You can draw the image, but draw it roughly. No need to draw like this, just sketch it. So please write electrical charge is the main thing, or electrical properties. The voltage is the number one. So just write down this quickly. Let me know once you're done.
Okay, sir.
Then the current, that is amount of flow, amount of the charge which is flowing, and the resistance is actually resist to the charge flow.
Okay, sir.
Resistance, the third property. Materials tendency to the resist. Actually, you have practical using different conductors for this. So I'll explain that next. Okay. So next is right here. You can see this shows you actually, yes. Right. I think now you know. So what will happen in this dry cell? So dry cell battery, actually electrical potential energy, how it happens, the positive terminal has higher potential than the negative terminal, right? That is basically electric potential energy to the electrical charges. We call the positive, that has higher potential than the negative. Actually, what will happen? The concentration of the electrons is high here. The concentration of the electrons is low here. And that is why there is a higher potentiality to provide power, because electrons travel other way, the power travels the opposite direction. So what is mean by this? So electrons are small particles, electrons in a dry cell. So how it happens? You can just see the flow. Actually, in a dry cell, here in a dry cell battery, you can see how electron flows, right? How electron flows in a dry cell battery. It's flowing from negative to positive here, negative to positive, then here to again. So because it's like basically flow in this direction, right? See here, let's see another animation. Okay, to study this, you can just try that lemon battery also. I'll show you that also. Let me show you how dry cell works. It's in this animation. Here you can see a dry cell battery. So this is used in most appliances, and actually this was developed by Carl Gassner in 1880s, right? 1880s, dry cell was developed. It's used everywhere, so you don't need like samples, you know that. So there is a positive edge and the negative edge. The positive edge has this so small pillar and the negative edge otherwise. So here this is another battery. This is 9-volt battery. Right? This is a larger one. It has more cells. Here the number of cells can be increased. Okay, how it works? Basically, so we learn about status of matter, right? And it took space and all. We just learn about the status of matter. And inside that, there are molecules, right? These molecules are made up with atoms, and atoms are having electrons. So this is the basic, actually, what is inside here. You can see the molecules, atoms, and then actually ultimately the electrons, protons, and all. Okay, this chemical reaction will happen inside. There's a carbon actually in the middle. Okay, as a result, you can see these electrons. These electrons, you can see it's traveling from this to this edge to this edge, the other edge. That is what happened in here. Actually, we call, right, the outside of this is called anode. The other one is cathode. This is positive charge electrode. This is basically graphite or form of carbon. Anode is zinc, right? Have you actually removed this outer cover and taken zinc for like this hydrogen to make hydrogen? In order to make hydrogen balloon, we are using zinc, which is outside, and this zinc we will react that with the battery acid, which is sulfuric, and will produce hydrogen. I think you have done that practical sometimes. If not, you can do that, right? So there is amount of zinc. So zinc layer is there, which is covering the battery. When this dry cell is not working, when these batteries are dead, basically the voltage is not there. You can remove the labels and all, and remove this internal stuff and get this anode, actually zinc. So that you can cut into pieces, and so that zinc will react with any acid. Basically, we are reacting that with sulfuric acid, which is battery acid. So that is, we are reacting with that to produce hydrogen, right? I hope sometimes you have done this. So zinc can be taken from this battery. Then see what will happen. Electrons are there in the negative or the zinc, right? In the zinc cover, there are electrons. So when negative is there, it's trying to move towards the positive. But it is not moving. When you connect the negative to positive, it moves through the wire. It moves through the wire. When you connect negative to positive, electrons in the negative edge will move through the wire to the positive edge. Actually, that is what happened. Have you tried connecting just wire? Battery and just wire, have you tried connect like this without a bulb? එහෙම connect කරලා තියෙනවා. The battery එක ධනයි ඍණයි දෙක විතරක් wire එකකින්. Have you connected like that? Yes or no? No. Yes. Aside say yes. So Sanidhi, no. Okay, anyway, so what will happen, side? So when you try to connect, what will happen? Positive and negative, they come connect. The electrons will go, but you cannot see that. So what will be the outcome? Yes, side, if you have done that, so what is the outcome? Not sure. Okay, try to connect using an aluminium paper, small aluminium paper, and put some cotton over there. So that is a small thing that you can do. You can just use a battery. I'm not sure that practical is there in YouTube. Aluminium paper and cotton. Actually, you can use them together. Can't see there. Okay, so let's say battery burn. So sometimes, okay, yeah. So let's try. I'm not sure whether this will work. Okay, actually he's using this bubble gum cover, right? So you can see here. He's using a battery, and so you can use a wire also, but here actually he's going to use this bubble gum paper, which is conductive material. It's a conductive material, right? You can use that paper. Can you see? Right? It will burn the paper. If you put some cotton there, it will also burn. Yeah, it will burn because it will become very hot. The reason is what? So the electrons are traveling so faster, the energies are traveling so faster because there's a conductor, and actually nothing is consuming these electrons. Nothing consumes the power. So power will be consumed by itself and it will burn. So that way you can even create a lighter. Right? Anyway, so if you try to a short pen again, circuit short pen again, bulb when there's a bulb will become hot. Actually, when power goes through the bulb will light up. We can do something. So that will also make the circuit hot, but that is not much affecting because there is a resistance. But if I make a directly connector, there will be very less resistance, and you are trying to send the power through the wire, and that will become hot, and that will ultimately create fire. When you connect the positive and negative, so make a local battery. So if you try to do this in a bigger battery, or a battery charge, some people when they want to check whether there's a charge or car battery charge, so what they're doing, they will put wire to positive edge and then try to short it to the negative edge. Then you can see some fire, right? So that is a way of checking a battery, but not a very good method of checking. What it indicates, the electron travels. When this electron flow is really when this voltage is high, it will spark. Touch spark because of the voltage. Voltage adu nam then battery එක බහැලා කියන්නේ voltage අඩුයි. Battery එකක් බහැලා කියන්නේ voltage එක අඩුයි ගොඩක්. එතකොට අච්චර spark වෙන්නේ නැහැ. ඒතකොට කියනවා මේ battery එක බහැලා. මෙයා ළඟට ගෙනියනකොට චිටිස් ගාලා spark වෙනවනේ. If it is sparking like that, so we call the battery has good power. Yes, we can use ammeter. We can use ammeter to measure it. Okay, so dry cell battery, we learn what happens inside, and there are different batteries. Actually, this kind of battery, the 12-volt battery or 9-volt battery, you can short it and see. But 3-volt battery, 1.5-volt battery that I recently showed on the multimeter. So the 3-volt battery and this 9-volt battery. 9-volt battery, you can of course see some power, but the 3-volt battery and 1.5-volt, you cannot see that much of voltage power because that voltage is very, very small amount. But higher the voltage, higher the power, right? Okay, voltmeter can be used to measure the voltage. Right, voltmeter can be used to measure the voltage. the amount of volt, or multimeter can also be used. Okay, so this is another practical which is listed here. I got a question. What is that? Yeah, 12-volt batteries, not just for the car, can be used for this bike as well. Bike vehicles is 12 volt battery, bikes, vehicles, electric vehicles, cars. Right? It can be used because 12 volt is a like commonly it's used in the industry. Right, so the difference between the voltmeter and the galvanometer, voltmeter is basically measuring the voltage, galvanometer is measuring the power, current. Actually, galvanometer and ammeter, so both are same, but the galvanometer is showing the direction also. Right? Galvanometer is showing the direction also, that is the major difference. So the direction of the current, not just the current, the direction of the current will also be displayed in the galvanometer. Okay, so here actually you are given few examples and asked to measure the voltage. We have done that. But you can see one more thing. The battery serial and battery parallel connection. I'm not sure whether we have done that. If not, let's do that very quickly using Tinkercad. As I remember, I have not done. I'm not sure. If I have done, please tell me. Let's use circuits. Create new one. New circuit. Okay, I think here, do I have voltmeter? No, I have only multimeter. It's okay, let's use that multimeter. And let's use a battery. A coin, okay. So let's use coin cell, few coin cells. Okay, battery parallel connection. One thing is you can connect these batteries parallelly. That means the positive edges, you can connect them together. You can see positive edges are connected, and then you can connect to multimeter or galvanometer or ammeter, right? Then the negative sides also, let's connect them together. And let's connect negative side also to the. Okay, when I try to measure the voltage, you can see voltage is still 3 volt. In the parallel connection, the voltage won't change. The voltage is 3 volt. Each one battery will have voltage 3. So here also 3, here also 3, but it is not adding up because we have connected parallelly. So you can see the voltage as 3. So if you try to measure the amperage, you can see amperage is 900 milliamperes. 900 milliampere is the amperage. Resistance, I'm not sure whether it's displays now because I'm just connecting directly. Voltage is 3 volt. Amperage is 900 milliammeter. So let me disconnect one battery in this. Now let's see what is the amperage. It is 600. So what will happen in the battery parallel connection? So when you increase the number of batteries, it will increase the amperage in the battery parallel connection. But so you can produce similar kind of thing here. Let me measure this. So let's measure the voltage. Voltage is anyway, it's 9 is mentioned there. So let's measure the negative to negative, positive to positive. So let's measure it. You can see it is 6 amperes. Means the flow of this battery is higher than flow of this coin cell. Coin cell has a very small flow. Coin cell battery podi. ඒ වගේ flow එක හරි චුට්ටයි. පොඩි current එකක් එන්නේ. So very small current, but here in this 9-volt battery, you can see it has 6 amperes. It's a very big current flow. In a pramana. Therefore, if you take very small amount of current, this will long last. This battery will long last because it has a lot of ampere. Okay, let me change this to the voltage mode. And you can see it's 9 volt, right? Okay, let's create 9-volt battery using 3-volt coin cells. So what I'm going to do is I'm going to connect this battery serial, negative to positive this time. Negative to positive. Not all the positive, negative to positive, and then take one from here. Oh, sorry. So let's use the multimeter, another one. Using the positive edge from here. Negative from here. Let's see what will happen. So both batteries, here the battery parallel battery serial connection. This is called battery serial connection. In battery serial connection, it will adapt the voltage. Now here 3 volt, here 3 volt, here 3 volt, the voltages will be added. Now earlier it was only 3 volt, but this time it is 9 volt. It has added that voltage. That both batteries having 9 volt now. Both batteries capable of providing 9 volt now. Okay, let's see the amperage. That is the problem. Let's see the amperage. It is 300 milliampere. It's only giving 300 milliampere. One battery will also give 300 milliampere. Here the battery parallel connection will also give 300 milliampere. But here the milliampere or the amperage is really, really high. So more powerful battery is this one. This is not much powerful, but still it has given 9 volt current. But if you try to use 9 volt current for long period, this will fail because this is not capable of keeping that 9 volt for long time because these batteries are very less powerful. It's having very less milliampere. I hope you understood the battery serial, battery parallel connection. Okay, so please write down there. Connecting batteries serial way. Connecting batteries in serial way. Then please draw this image. Please draw this image. This has actually a coin cell battery image. We'll be taking this one. So what will happen? It will add voltages. So 3 volt plus 3 volt plus 3 volt is equal to 9 volt and keep same amperage. Keep amperage. Okay, so then connecting batteries parallel way. So how do I connect the batteries parallel way? Positives to the positives, negatives to the negatives. So let's remove this. Positives to the positives and sorry. Negatives to the negatives. Positives, positives to positives. Negatives, negatives to negatives. You can see it has increased the amperage, but keep the voltage as it is, right? Keep the voltage as it is, only 3 volt. So please, okay, I hope you have done this part, right? Quickly do it if you're not done. Please do this quickly. Okay, I hope the time is enough. If not, please take a screenshot later at this. Connecting batteries parallel way, please draw that. This is what the parallel connection is. What will happen to the voltage? Voltage will increase definitely. This is parallel connection, right? Sorry, voltage will remain same. The voltage is 3 volt, you can see. But keep same, it will add the amperes. It will add amperes. Actually 300 MA plus 300 MA plus 300 MA. This will be 900 MA milliamperes, and keep the same voltage. It will keep the same voltage. You can see it's only 3 volt. It's not changing the voltage. Please draw that as well. Okay, I hope it's done. Right, the next. Okay, so here actually you can see some images. So repairing electrical appliances, when there is like more voltage, I said that, so volt 12 is also okay, it's also tolerable. That won't give you electric shock. But so when you try to, here actually this image showing how to measure the voltage around the battery and voltage around the battery, and when motor is also connected, what will happen to the voltage? Actually voltage will be shared because you are trying to share the voltage with some other device. So you have to do this measurement. Actually this can be done here in our what you call, so you can add the same thing, right? You can do this with so what is the kind of battery? You have 2 batteries here. Let's use 2 AAs. Very quickly create this. I'll show you how to do practice, right? Add in 2 AA batteries like this. Okay, then what? Then a bulb. Okay, what is this bulb? So let's take LED, right? Or just take a general bulb, but I'm not sure whether this general bulb will turn on. Let's try. Is it working? Yeah, it's working. Doesn't matter, it's working. Then a motor. DC motor. DC motor. Okay, this one. So DC motor, you can give any side, like the positive and negative, you can even change that. So if you change that, what will happen? The rotation side will be, so how they have connected, this is the battery and the bulb, and one edge of the bulb is connected to, this is the positive, let's connect to this, and then this is connected to here. Okay, that's right. And now you can see the bulb is also working, the motor is also rotating, right? Showing 3363 RPM. Now what? Now we are going to measure the voltage. Okay, voltage around this can be measured, like the negative can be connected to the negative one. Stop the simulation. Negative can be connected to the negative one. The positive can be connected to the positive terminal. Let's measure it. So what is the voltage around the bulb? You can see it's getting 1.29 volt. Here actually 1.5 volt, 1.5 volt together. So what is the voltage? You can check that too. Together, what is the volt? Oh, just remove the motor and see what will happen. Okay, now the positive edge need to be connected here. Okay, when you play this, you can see it's getting closer to 3 volt. Right? Closer to 3 volt is consuming by the. But what will happen when the motor is there? The motor will also share some portion. The terminal, this can be connected. Okay. This. Start from the terminal, right? Okay. The positive, let's connect to this one. When there are two devices, it will simply share it. So let's measure this around both motor and dekama, let's motor. Let's measure it from here to here. So then you can see it's the total is there, 12.9. But actually, if you try to see what is the motor, what is the amount that motor takes, you can see motor will take around 1.6 volt. The motor takes high voltage, but battery has taken, so that depends on the device. Okay, that also you can. So these practicals you can do. That's why I'm telling. So no need to arrange the lab work, but just you can use this and do the practicals. Okay, please practice this. So there are few, I think the resistant part we need to do, very small part. I'll keep it to the next day. But before that, so please practice these circuits, whatever the circuits you see, we are listed here. Practice this using the parallel connection, serial connection, and also with the measurements. Try to measure for the different units and measure the amperage also. I have just measured the voltage. Try to measure the amperage too. So please complete these practicals with Tinkercad. Okay, I'll be doing the remaining part, the last part of this lesson next day with the questions. Right? Then good night.